So today we are going to do gas laws. So last year we did a separate one each day. This year, because it's review, we're going to break them into parts. So this is gas laws, part 1. Okay, we're going to start with boil. If you look at the formula sheet, Boyle, it says that he is P1 V1 equals P2 V2. So pressure and volume. I'll write out the problem. Okay, so Boyle's law, P1 V1 equals P2 V2. A sample of gas occupies 12.0 liter under a pressure of 1.2 atm. What would its volume be if the pressure were increased to 3.6 atm? Okay, so let's figure out here. P1, V1, P2, V2. Okay, so our P1 is 1.2 atm. Our V1 is 12.0 liter. Our P2 is 3.6 atm. And our V2, we have no idea. Okay, so we're going to punch that in to the formula. 1.2 atm times 12.0 liter equals 3.6 atm times V2. Okay, so you're going to use your algebra skills, hopefully, and look at this and say, I need to get V2 by itself. So if you divide both sides by the 3.6 atm, then the 3.6 atm on this side cancels out. That gives you V2 by itself. The unit atm cancels out on this side to leave you with just the unit liter. So now you're going to punch into a calculator 1.2 times 12 divided by 3.6, and you should get 4.0. Again, your unit is liter. And this is your answer to boil. Okay, I'll give you just a little bit there to make sure you got it written down, and then we're going to move on to our next one, which is Charles. Okay. Okay, if you look at your formula sheet, Charles is V1T2 equals V2T1. So volume 1 times temperature 2 equals volume 2 times temperature 1. the gas in a balloon occupies 2.25 liter at 25 degrees Celsius. At what temperature will the balloon expand to 3.50 liter? Okay, hopefully it's starting to come back to you from doing these last year, and you're remembering that with temperature cannot be degrees Celsius. Temperature we do in K or Kelvin. Okay, so let's do V1, T2, V2, T1. And a lot of you want to skip this step, but I find it helps to write it out and put it that way and put this T2 here, because that's the main mistake that everybody makes, is putting them in the wrong order. So if you have them written out in the correct order here, it usually helps you when solving. Okay, so let's start with volume 1. Volume 1 is 2.25 liter. And then T2, we do not know. That's the question. At what temperature will it expand to? Our V2 is 3.5 liter. And our T1 is 25. So again, you've got to get that in Kelvin. And your formula sheet tells you temperature, degrees Celsius, plus 273 gives you Kelvin. So we've got 25 plus 273, and that will give us 298 Kelvin, or 298 K. So now let's punch that, or put that all into the equation, or the formula. So V1 first, 2.25 L, and T2, don't know, equals, and then we got 3.5 liter, and we've got 298 K. Again, from algebra, so you remember that you need your T2 by itself. So we divide both sides by 2.25 L. This makes these cancel out. Gets our T2 by itself. Our unit of liters cancels out. We take 3.5 times 298 divided by 2.25, punch that in, and hopefully you get 464 K. Okay, so that is our answer for Charles. Okay, we're doing one more today, and that's Lusac. Make sure you get a chance to write that down. We're going to ignore my phone. I'm up here on a Sunday afternoon getting all this ready. All right, here we go. Okay, Lusac's law. All right, Lusac, if we look at the formula, Lusac, it says P1T2 equals P2T1. Okay. My daughter got a gizmo watch and can now use it to call me. Okay. So P1T2 equals P2T1. Okay, I think I can pause. I'm going to pause real quick and we'll come right back. Okay, so anyway, we're on Lusac. We look at Lusac's law. Lusac's law is P1T2 equals P2T1, and let's write that up. Or the problem. pressure in an automobile tire is 1.88 atm at 25 degrees Celsius. What will be the pressure if the temperature warms up to 37.0 degrees Celsius? Okay, something we don't think about, but real world, we just drive our cars and don't think about the pressure, the tire pressure, except when a light comes on, or if you don't have a fancier car for that, then when you notice that your tires are getting low. So this is something that in the automobile industry, especially the tire industry, that they notice and that they have to pay attention to, because they have to make sure their tires can withstand a certain amount of pressure or they're going to burst. In racing industry, this is a huge thing, trying to figure out, how much heat that they can generate and get that pressure up but not burst the tire, and how to make those tires that way. All right, so let's go ahead and do our setup. Okay, our P1, it says, is 1.88 atm. Our T2 is 37. We got to add 273 to that, which is 310K. Our P2, we don't know. It says what will be the pressure. And our T1 is 25 plus 273, and that's 298K. Again, big mistake with these. Usually everybody kind of finds this easy, but they flip their temperatures. So make sure you don't do that. Okay, let's go ahead and plug it into the equation, or into the formula. We have 1.88 atm times 310K equals P2 times 298K. We want our P2 by itself, so we divide both sides by 298K. This gets rid of the 298 on that side, gets rid of the unit K on this side. We take 1.88 times 310 divided by 298, punch that into a calculator, and it's 1.96 atm. And that is our pressure. Okay, so that's our gas laws 1 today, doing Boyle's, Charles, and Lusac. And so Miss Thomas will give you a worksheet over those, and I hope that you have a great day.